Hello everyone, welcome to this section. In today's video, we're going to talk about exception handling in Python. So what is exception handling? In fact, exception handling in Python allows us to manage errors that occur during the execution of a program. So by using exceptions, we can prevent our program from crashing, and instead we can handle errors gracefully. So, for example, there are three common errors that we may have, for example, in Python or any other programming languages. For example, if we try to divide a number by zero, so we will have zero division error. It's not possible to do that in reality. Or if we want to access a variable that does not even exist, we are going to have name error. Or trying to open a file that does not exist, we are going to have file not found error. For example, here, I am having an example here, division by zero exception. So here, x equals 10 divided by zero. So this division will lead us to zero division error. And when I run this code, we see that there is a red line here. So we are having an error here. So the reason is because we cannot do this mathematically speaking, and we see it here, zero division error, division by zero. Okay, so it's not possible to do that. And also, another example here could be accessing an undefined variable. Here, I'm trying to print a variable called name that is not defined. So when I run this code, we are having errors, so the program crashes. So exception handling is going to help us to deal with these errors and prevent the program to be crashed. Here you see that it says name is not defined and we are having the program being crashed. So we need exception handling in order to prevent this crashing. This is why exception handling is very important. In the following videos, we are going to dive deeper into this concept in Python. Thank you for watching. Hi, welcome back. So in today's video, we would like to use basic exception handling using try except. So the try except blocks handles exceptions and prevents program crashes. In the previous video, we saw that if we would like to divide 10 by 0 and assign it to variable x, we are going to have the program being crashed. In order to prevent that, we learned that we can use exception handling. So here, in order to use the exception handling, one example is try except block. So we type down try and then colon, then do the risky operation. So if we would like to do something risky, or we know that the code that may have an error, or we are providing a program for our user and the user may have some potential mistakes when they are, for example, entering their input, we need to use try and except, or in general exception handling, in order to prevent the program from being crashed. Here I'm using the try block, and then here I type down whatever I want to do. For example, x equals 10 divided by 0. And then, for example, we can print x here. And then we are having the except keyword and then colon, and we are printing out an error occurred. So when I run this code, we see that the output is an error occurred. So what happens here, it is going to execute this code and sees that there is an error. But because we are using exception handling, it is not going to allow the program to crash, and it is going to accept, apart from preventing the program to be crashed, it is going to throw an exception. So this is the exception that is being thrown. It shows this message: an error occurred. But if we correct this mistake, for example, if I type down 10 divided by 5 and then print x, it is going to show us the number 2. But if there is a mistake there, it is going to understand that there is a mistake, and for that it is going to throw an exception and shows this message. So comes to the except part and then print this message in the output. When I run the code again, when I divide 10 by 0, we see that we are having an error occur. So this is why exception handling is very important, because in the very same example we saw in the previous video, if we want to have a number divided by 0, we are going to have the program being crashed. But here we are making the same mistake, but thanks to the exception handling and try except block, we are preventing program crashes. We are saying that, okay, do this. If there is any problem, throw this exception. Otherwise, if there was no problem, print X for me. So here, when I divide 10 by 5, there is no problem here. So it is going to check this out and print the value of X for us in the output when I run the code now. You see it here. But if there is an error or there is a problem, it is going to say, okay, there is a problem, let's throw an exception. So this is the except part when it is being activated, and this error is shown in the output. So this is how basically we can use basic exception handling using try except block to handle exceptions and prevent program crashes in Python. In the following videos, we are going to dive deeper into this concept. Thank you for watching. Hello everyone, welcome back. In today's video, we are going to talk about catching specific exceptions. Here in Python, for example, we are having some predefined errors that we may be able to catch them using exception handling. In fact, here zero division error or value error are already defined in the exception handling system of the Python. So for example, value error is when we would like to have a variable, but value error when the value of a variable is not correct. So when the value of a variable is not correct, the Python system is going to handle it through a value error exception. And if we are using try except blocks, it is going to throw this exception and show us this message, for example. But if we are not using the try except block, it is going to crash the program. So the program is going to be crashed. Also, when we are having, for example, zero division error, it is going to evaluate to see if a number is divided by 0 or not. So if a number is divided by 0, it is going to automatically understand that we are going to do an error for this category, for example, zero division error. And therefore, if we are using try except blocks, it is going to handle it using this error handling in Python. Otherwise, it is going to crash the program. So let me illustrate all these concepts with an example. We are showing this message to the user, enter a number, for example, here. And we are going to use the input in order to store it. And then because it's a number, we want to convert it to an integer and assign it to a variable called num. Then we are dividing 10 by num and assign its value to result. Okay. Then we would like to, for example, show this in the output. For example, print result. Okay. However, if during this procedure something happens or an error is thrown because we are putting it in the try except block, it is going to understand it and it is going to throw an exception. And depending on what we do with this num, it is going to have different exceptions to be thrown. So let me run the code. So when I run the code, it says enter a number. We are in this line. Now I type number 5, for example. It says the output is 2, for example, here. Because when I type number 5 is stored in the num variable and 10 is divided by that num variable So 10 divided by 5, the result is 2, and 2 is assigned to result variable, and we are printing out the result variable. Okay, let me run the code one more time. So here there was no problem, everything was fine. Simply we were just using the try except block in order to prevent any program crashes, and nothing went wrong. When I run the code one more time, it says enter a number. So here I type down, for example, 0. So when I type 0, it is stored in the num variable, and 10 is divided by 0 and assigned to result. At this point, because it is not possible to do that, it's not going to continue executing the program anymore, the compiler. And then if we are using try and except block, which is our case, it is going to throw this exception. And because if this exception is thrown, we are going to have this message in the output. It is going to show this message in the output for us. But if we were not using this try and except block, it was going to have a program. We were having our program being crashed. So now I enter 0 in the output, in the input, and it says cannot divide by 0. So this message is shown because this exception was thrown. This is why we have this message in the output. So if I run the code one more time, it says enter a number, and this time by mistake I enter a letter, for example, a character like H. So enter a number, I'm entering H, and 10 is divided by H. So it is going to throw an exception in this category, value error, when the value of a variable is not correct. So if I enter, it says invalid input. Please enter a number. So this exception handling part, so if we throw this exception, and then because we've thrown this exception, this message is shown in the output. So this is how actually we can have specific exceptions being handled in Python. And we had an example here of a number divided by 0 or a number divided by a character, for example. Thank you for watching. Hi, welcome back. In today's video, we're going to learn how to catch multiple exceptions at the same time in one except block. Here, I would like to, I'm having a number with decimal values, for example, 2.5, and I would like to convert it to an integer and then print its value. So first of all, 2.5 is converted to an integer and is then assigned to a variable called x. Then we are printing this variable x. So when I run this code, it says the output is 2 because we converted it to an integer. So now there is no problem because we are using the correct format, okay? However, because it is a bit risky, we are using the try and except block to perform this task in Python. However, if instead of having 2.5, what if I type down a string? It is going to have an error, and the error comes from the value error. So in the except part, if you see, we are having two errors being handled at the same time. So value error or type error, and then we are showing this message error occurred. Okay, so when I run this code, we are going to have value error. Okay. So it says error occurred, invalid literal for int, okay, with base 10. ABC is a string and it's not going to be converted to an integer. It's not possible. So it's a value error, and here the value should be something different. Okay, so this is how the value error works. When the compiler sees that we are having a problem here, it stops executing the program, and it is going to throw an exception. And this exception is caught by our except block. So this value error is taken and the message is shown in the output. But instead of this, for example, if I have, for example, a list or a dictionary or a tuple, we cannot convert a list to one integer. So when I have a list, for example, this will cause us the type error in this time, type error, because this type is not handled here. Okay, so when I run the code, we are again seeing error occurred, but this time it says argument must be a string, a bytes-like object, or a real number, and not a list. So this is the error that we are seeing in the output. But if we do it and we don't use try and except block, we are simply having the program being crashed, and we have no idea why the program is crashing, and we need to do a lot of debugging to understand why the program is crashing. However, when we put the risky parts of the code in the try except part, it will help us to catch these information in the output, and we see, okay, we made a mistake there because we are trying to convert a list to an integer and it's not possible. For example, I need to put a float number there in order to be converted to an integer. So I replaced that list with 5.5, and now we see that no errors is occurred, and here the output is 5 because it is converted to an integer. So it's very important to use exceptions in order to have a better code when we are having a problem, when we are having a crash. We will not have a crash. This is the first thing. And the second thing is when we are having a problem and an error message in the output, we can trace it very easily. And here we learned how to have multiple exceptions being handled at the same time. Thank you for watching. Hello everyone, welcome back. In today's video, we're going to talk about finally block. So the finally block always executes, even if an exception occurs. Here is an example. First, I illustrate my explanation in an example, then I say why we need to use finally blocks. Here is a try and except block, and in the end we are having the finally blocks. For example, in the try block, we would like to make sure that we are opening a file and we are, for example, reading the data. And then if there was any problem, we're going to throw an exception, and this exception is caught by the except block and saying that file not found. For example, if the file is not accessible, we are going to show this message in the output. And then using the finally block, we are making sure that we are closing that file. Okay, so even if the error occurs, the finally block ensures that this file is closed and this part of the code is executed, preventing resource leaks. Okay, so even if there is a problem, we are going to make sure that this part of the code is executed. So when, for example, when there is a problem here, okay, the compiler is going to stop there and throw an exception. It's not going to continue implementing the code. So it is going to throw an exception and show this message in the output. However, anything that is inside the finally block is going to be executed. Therefore, here we are making sure that in any case, if we are having an exception or not, we are going to make sure that we are going to close this file. Therefore, we are preventing resource leaks. So no matter what happened in the program, the finally block is going to be always executed. So it is useful because it ensures that certain cleanup code runs no matter what happens in the try or except blocks, and it executes even an exception occurs, even if an exception occurs, or if there is a return break continue statement inside the try or except blocks. So we now understand that whatever is going to happen, we are we are assured that the finally block is going to be implemented and executed. And some usefulness of finally block is resource cleanup, for example, closing files, database connections, or network sockets. Or we are making sure releasing locks. So we are ensuring locks are always released after an operation. And logging and debugging, guaranteeing logs are written even if an error occurs. Okay, so if we want to have certain messages to being printed in the output for you, you need to put it in the finally blocks because we are making sure that whatever is there, it is being executed. And the fourth usefulness is ensuring critical code runs. Any operation that must execute regardless of exceptions, we need to put it in the finally block. So let me illustrate it with an example here. So now I uncomment this part. Here I'm trying to print the output of 10 divided by 0, and as we know, it is going to throw an exception. And this exception is caught by an error occurred. Okay? Here, when I run this code, we see that an error occurred. This part is being printed in the output, but also we see that this message, which is for the finally block, is being executed. This will always execute. Okay. For example, the program has reached to an end. Okay, for example, we want to show this message. Or if you're having some debugging logs there, you want them to be printed out in any case, even if we are having an exception, you need to put it in the block, in the finally block. And even if we are having no exceptions here, for example, print 10 divided by 5, it will throw no exceptions. Okay, so it is going to show us the output. So when I run this code, it prints the output number 2, which is the output of this part, and this part is not executed because there is no error. However, we see that the program has reached to an end message is being printed out in the output. So finally block is going to be always executed no matter what. This is very important because we can use it for debugging, for closing the files, making sure that we are having no leaks of the resources. Thank you for watching. Hi, welcome back. So in today's video, we're going to learn about the else block. The else block is going to be executed only if no exception occurs. So if everything goes well and you have no errors and no exceptions, the else part is going to be executed. Otherwise, if you have an error and if you have an exception, the else part is not going to be executed. Let me illustrate it with an example here. Here I'm I'm showing this message to the user saying that enter a number. Whatever the user is going to enter, we're going to convert it to an integer and assign it to variable called num. And then we're going to print the number that is entered by the user. Okay. If there is an error in terms of value error, so if I, for example, enter a string or enter a character, it is going to throw an exception and it is a value error and it is caught by the except block and it is going to show this message invalid input, please enter a number. Okay. So if there is an error, this part is going to be executed. And if there is no error here, this part is also going to be executed. Let me illustrate it with an example. For example, enter a number. I enter a character. So when I do this, it shows this message, invalid input. Please enter a number. So this part is being executed. Why? Because we had a value error and it is caught by this except keyword or block, let's say, and this message is shown in the output. And you see that this else part is not being executed. Why? Because we are having an exception. We said that these two are not going to be executed at the same time. if everything goes well, the else part is going to be executed. So it says enter a number. Now if I enter number 10, it is going to show this message to me first of all. You entered, and then this number 10 is being shown in the output. And then this else part is activated, and this message therefore is being shown because this part is inside the else block. So it says no errors occurred. So as you see it here. So the else part is very useful because when you're having, for example, multiple try except parts in different parts of your code, you can trace them and you can print some values. For example, here you can say no errors occurred from the first operation. Okay, so when I run this code and I enter number 20, it says you entered 20 and no errors occurred from the first operation. And I may have like 10 operations. And when I see the print of 9 of them, and I see the print of the, for example, I don't see the else part being activated for the fourth operation, and I'm having also an exception being thrown in the output. The error is shown there. I can easily understand, okay, the fourth operation is having some problem, therefore this exception is caught in the fourth operation. Just imagine that instead of only this, okay, we are having multiple of them. For example, we are having one here, and this is the second operation, second operation, and this is the third operation, for example, and the problem comes from this part, okay, because this else part is being executed and shown in the output, so no errors occurred. This message is shown in the output for the first operation, and for the third operation it is also shown. However, in between I'm having one exception being caught, so I can see that the first operation and the third operation, they are shown in the output, and I'm having an exception, therefore it comes from the second operation. It's very useful to have it, and it will help us to trace the error very easily and make sure certain part of the code is being executed correctly and in a clean way. So in this video, we learned how to have the else block in the Python and how it works and how it is executed. Thank you for watching. Hi, in today's video, we're going to learn how to create custom exceptions. In order to create custom exceptions, we're going to use the raise keyword and exception built in. Okay, so here is an example. Let me illustrate it with an example for you. Here in the try block, we are calling the check age function and we are passing one argument, and this argument is -3. So when we call this function is declared here. This function checks to see if the passed argument, which is age, is lower than 0 or not. So if it's not lower than 0, it is going to say, okay, valid age, then print the age. If it's lower than 0, however, it is going to raise an exception. So raise an exception here stops execution of the program and throws an error when age is negative. So when we would like to trigger an error manually, we're going to use the raise keyword. So I type down the raise keyword and I use the built-in exception. Then in parentheses, I type down the error message that I would like to be shown in the output. Okay. And then this part is finished. So an error is thrown and it is caught by this part. So the except part is going to caught the error and then print the error here in the output. So the way that the program works is the following. So if we're calling the function with a negative number, it is checking it and it says that it's a negative number, it is going to throw an exception and it is going to cut the exception here in the except part and then print the error message for us. However, if we are calling the function and we are passing a positive argument, simply it is going to say that valid age and print the entered number here. So for example, if I enter number 10 and I run the code, we see that in the output it says valid age 10. So when I come here, I see that I'm calling the check age function and I'm passing number 10 as the argument. Then in this function, what happens is the following. 10 is lower than 0. Is it true? No, it's not true. Therefore, this condition is not true, and therefore, this block of code is not going to be executed. However, the print part is going to be executed because it's not a part of the if condition. It's a separate part in the check age function. And we are going to have the valid age message here, and then the number 10, which is the entered age as 10 as the argument, is shown in the output. However, if I change this number and I enter, for example, -3, it's a problem because we cannot check, for example, a human age when it's negative. So it's an error caused by the user, let's say. So we are using the try except block in order to prevent program crashing. Okay, so the crashment of the program is being prevented using try and except block. So when I run the code now, we see that in the output it says age cannot be negative. How come it happens? So in the try block, we are calling the function and passing -3. And this function is called. Now this condition is checked. So -3, is it lower than 0? Yes, this statement is true. Therefore, because this statement is true, we are throwing an exception, and the message for the exception is age cannot be negative. And this thrown exception is caught by the except part here, and then we are printing out the message in the output, which is this one, age cannot be negative. So in this video, we learned how we can create custom exceptions, and this is done using the raise keyword. The raise keyword triggers an error manually. Thank you for watching. Hi, welcome back. In today's video, we're going to learn how to catch a division by zero exception. We are going to write a program that takes two numbers as input from the user and divides them and handles zero division error. So we're going to ask the user to enter two numbers for us, and then we're going to do the division with these two numbers. And because the users may make some mistakes, we are going to use try and except blocks in order to prevent program from being crashed. So here we are saying that enter a numerator from the user. We are assigning it to variable a. Then we are saying that okay, enter denominator, and then we are assigning it to b. Then we are having a result variable equals a divided by b, and we are showing the result in the output. However, if there is a problem in this code that is being executed, for example, if b equals 0, we are going to throw an error and caught it with the except block, and it is zero division error, and then we are going to show this message. Okay, error cannot divide by 0. So when I run this code, it says enter numerator. I enter, for example, 10. It says enter denominator. I would say, for example, 5. It says result is 2. So 10 is stored in A, 5 is stored in B, and the output of A divided by B is stored in result, and then we are printing the result in the output. However, if I'm having, for example, the first number, the numerator to be 20 and the second number to be 0, it is going to throw an error, and this error is caught by the except keyword and it understands that it's a zero division error. Here it shows the message cannot divide by zero, and because it is caught as the zero division error, this part is going to be executed in the output. So this is how we can read two inputs from the user and divide them and handle zero division error in case the user is going to make some mistakes. Thank you for watching. Hi, welcome back. In today's video, we're going to talk about handling invalid input. So we would like to write a program that asks the user for an integer and handles value error if they enter a non-integer. So here is my program. I'm doing my program in the try block because I'm assuming that the user may make some mistakes at some point and I don't want my program to crash. Therefore, I am writing it in the try block. So I ask the user to enter an integer. Whatever the user is going to enter is going to be stored using the input function, and then it is going to be converted to an integer, and then it is going to be assigned to the num variable. And then we are going to show this message to the user saying that you entered and show the entered number by the user. However, if the user is going to enter anything but an integer, we are going to have a value error, and this error is caught by value error using the try except block. And then we are going to show this message in the output. Print error, invalid input, please enter a number. So the compiler understands that we had to enter an integer because we are using the integer keyword, but we are not entering an integer. Therefore, it understands that it's a value error. Okay, so when we have the value error keyword here, it is going to say, okay, yes, the user is making the value error and the programmer has used the try except block. Therefore, I can throw an exception and show this message in the output. However, if we were not using the try and except block, the program would have crashed when the user is going to enter, for example, anything but an integer. So when I run this code, it says enter an integer. I type down, for example, 20. So 20 is stored in num, and then we are having it in the output. You entered 20. So this is the output. Okay, so no problems happened. Nothing happened. We faced no problems because everything went correctly. We were supposed to enter an integer and we entered an integer, in fact. However, if we type down, for example, a character instead of an integer, for example, I type down C. So when I enter C, the compiler understands that we were supposed to have an integer because we use the int keyword here, but the user is entering a character. So it's not of the same type that we were expecting. So we were expecting an integer, but the user entered a character. So it is a problem. Therefore, the compiler understands that it's a value error. So, and we are having the value error keyword in the try except block. So the compiler says, okay, we are having the value error try except block. Therefore, let me throw an exception. And this exception is caught using the except keyword and then the value error. And then this message therefore is shown in the output. Invalid input, please enter a number. However, if I was not using the try and except keyword, we were just having the program being crashed as we showed in the previous videos. So let me run the code one more time. I type down W and it says invalid input, please enter a number. And I run it one more time, and this time I type down, for example, 12. We see that there is no problem, no error is thrown, therefore no exception is thrown, therefore we are having the you entered 12. So the 12 is shown in the output. Thank you for watching. Hi, welcome back. In today's video, we would like to do handling multiple exceptions. We would like to write a program that takes an index, for example, from the user, and accesses a list at that index and handles both index error and value error. Okay, so here is my list. It has 4 elements. This one index is 0, this one index is 1, this one index is 2, and this one index is 3. So we are having 4 elements from 0 to 3 is the indexing of this list. Then we are asking the user to enter index. Okay, so whatever the user is going to enter, it is going to store in index variable, and then we are showing this element of that index. So we say value at index. For example, imagine the user enters number 1. Now 1 is stored in the index variable. Then we say value at index, and then we show that index of the list. So the indexing in this list is here because we start from 0. It's like this. Okay, so when we type down index 1, so 1 is stored in index variable, then we're calling that index from the my list. Okay, so it's like I am calling the my list and then with index 1, and index 1 is element 20. So we are going to print the value 20 in the output. However, if we type any index apart from these ones, we are having index error. Okay, because it's out of range. So we are going to show this message in the output, index out of range. Why? Because we are having only these 4 indices. If I type down index, for example, 10, it is going to raise an error, and the error is index error type. And also, if instead of typing down a number, I type down a character, for example, we are going to have an value error. And we are going to, if value error is caught, we are going to show this message in the output, and error, enter a valid number. So let me run the code one time. It says enter index. So I type down 1. So it is saying that value at index 1 is 20. This is number 20 is shown in the output. You see it here. And so 1 was stored in the index variable. Then we are using the print function to print this number 20, which is the element of the my list with index 1. However, when I run the code one more time, if it asks me to enter index and I type down, for example, number 10, and we see that in this list, we have no element that has an index of 10. So it's an index error. It's out of range. So we are going to throw an exception. So the compiler is going to throw an exception of index error, and thanks to the try except block, we are not having our program being crashed, and we are showing this message, error, index out of range. So we understand, okay, there was a problem. So if the user comes to us and say, okay, you programmed this for me, and now instead of showing me, for example, the number that I'm looking for from the list, it is saying that index out of range. And right away, I understand, okay, there is a problem in the input that you are entering. Okay, so we can understand and debug the program quite easily using try and except index handling exception. So when I run the code one more time, it asks me to enter index. And this time, I don't want to enter, for example, an index. I would like to type down a character, for example, by mistake, if the user is going to enter K. When I type down K and I enter, it's a value error that the compiler understands. Why? Because we were supposed to enter an integer, but we didn't do it. We typed down a character, so it's a value error. Therefore, it is going to raise an exception, and this is called by the value error block, and it is going to show this message, enter a valid number. So you see it here, error, enter a valid number. It is shown in the output. So for example, if I type down index 3, for example, it is showing value at index 3 is 40, which is this number. And this is exactly true because the index 3 is for the element 40. So in this video, we learned, first of all, how to handle multiple exceptions, and also we learned how to work with the program in a way to avoid having index error as well. Thank you for watching. Hi, Welcome back. In today's video, we would like to write a program that simulates a bank account. For example, a person would like to withdraw some amount of money from the bank account, and there is already an initial balance in the bank, and the person would like to withdraw some amount of money. So if the withdraw amount is lower than the balance of the bank account, there is no problem, everything goes well. However, if the withdrawal amount that is entered by the user is larger than the balance in the bank account, we are going to have a problem. And we are going to try and use the try except block to handle this error. Okay. Here is the initial balance. So the variable balance is assigned to $500, for example, and then we're calling the withdraw function, and then we are passing two arguments. One, this is the balance variable which we initialize to be 500, and then we are passing the withdrawal amount. For example, the user would like to withdraw 400 from the account. So the output of this function is also assigned to the balance variable. This function is called. First of all, we're going to check if 400, the amount, is larger than the initial balance. So 400 is larger than 500? No. So this part is not going to be executed. Then that amount is reduced from the balance, and we are showing it in the output saying that the new balance is, and we are showing the balance value. So this part of the code basically says balance minus amount. Okay, this equation here equals this one exactly. It depends on you. So if it's more convenient for you to type it this way, type it down this way. It's okay. So 500 minus 400 is 100. So the new balance after withdrawal is calculated here. So 100. And we are showing this message using the print, saying that, okay, new balance, and the balance is being printed out in the output, which is 100, and we are returning this balance. So balance is assigned, which is the output of this function, is assigned to the variable called balance. So balance is updated. However, if the amount is larger than the balance, for example, the user wants to withdraw 600 while the balance is 500, we are saying that, okay, if 600 is larger than 500, it's true. So we are going to, this condition is true. We are going to execute this part of the code, and we are going to use the raise keyword to trigger an error manually, and the error is the value error, and we are going to say insufficient balance. So we are throwing an exception, and this exception is caught here using the except block, and then we are printing out in the output error, and then insufficient balance is shown in the output. So let me run the code. When I run the code, it says new balance 100. Why? Because the balance is 500 and I would like to withdraw 400. But if I want to withdraw, for example, 250, it says new balance is 250. If I want to withdraw, for example, 150, it is going to say new balance is 350. So the balance is being updated using this line. Okay. However, if I want to, for example, withdraw 700 while the balance is 500, it says 700 is larger than 500. We are going to throw an exception, and this exception is caught here, and this message is shown error, and then this message is shown in the output. So when I run the code now, we see that it says error, insufficient balance. So here is how a banking system would work usually in any country. This is how we can use the try except block to prevent the program from being crashed. So when the user enters one amount that it is larger than the balance, the user wants the output, to see the output, okay? When they're using, for example, an ATM. But if we're not using try except blocks, the program is going to crash and the user sees nothing. says error, for example, but we need to show some message to the user that they are making a mistake in their input. And this is the message: insufficient balance. So they understand, okay, I'm trying to withdraw some amount of money which is larger than the balance of my bank account. So, okay, I need to reduce the amount. So this is how we can solve actually the problem. Thank you for watching. Hi, welcome back. In today's video, we are going to simulate a login system. Here we would like to write a login system that raises value error for invalid usernames. Okay, so let me run the code first. It says enter username. I type down, for example, admin, and it says enter the password. I would type down 1234. It says login successful. However, if I, for example, type down a user that is not valid, for example, my admin, and I enter, for example, a wrong password, it says user not found. Okay. Or if I enter the user correctly, but I enter the wrong password, it says incorrect password. Okay. So how do we do that? We need to simulate a login system. To do that, we are having a dictionary here defined, and there are two, for example, let's say usernames called admin and user. And the password of admin is 1234, and the password of the user is ABCD. So we are having two usernames, admin and user, and two corresponding passwords respectively. So anything that is not inside this dictionary is a wrong username or password. If the user is going to enter one of these usernames and their corresponding password, they're going to have the access to the system. Here we are asking to say, okay, enter the username. We're going to store it in the uname variable, and we're going to say enter password. We're going to store it in pwd. Then we're calling this function and passing these two arguments. Okay, uname and pwd, these are the things that we read, we got from the user. And we are saying that if for each username that is not inside the users, okay, raise an exception, and manually we're doing it, and the exception is value error. For example, say user not found, and when it is not found, user not found, exception is thrown. We're going to catch this exception using the except part here, and then we are showing this message in the output, okay, error user not found. And if the user name that the user is going to enter is, for example, a correct username, we are not going to enter this if condition. Then we are going to check the password. Okay, because we would like to check the password, we are checking if the password that the user entered equals to one of these two passwords. Okay, one of these two passwords. If they are correct, we are not going to enter this part, and we are going to show this message, login successful. However, if the password that the user is going to enter is neither this nor that, it is going to throw an exception, and the exception is from the value error, and it is going to throw this exception with the error incorrect password. And this exception is caught using this except block, and it is printed in the output. So let me review it one more time. We're going to enter the username and the password. If the username is not inside this user's dictionary, so if the username is neither admin nor user, we're going to throw an exception, user not found, and the exception is called here and shown in the output. And the program is finished. But another time we're going to try. Now we are entering a username and password. This time the username is correct, but the password is not correct. So the username is correct, so we are not going to throw an exception here. because the username that the user entered is indeed inside this this dictionary, sorry. So this part of the code is not going to be executed. However, the password is not correct. Because the password is not correct, we are going to throw an exception incorrect password, and this exception is caught here in the except block, and we are showing this error and then incorrect password. In the first scenario, if we enter the username and password and both of them are correct, we check the username is not inside this dictionary. No, it's not true. It's inside. So the username is correct. We are not going to execute this part. No exception is thrown. Then we check the password and we see the password is also correct. So no exception is thrown also here. And therefore, this message is shown in the output. Login successful. So let me run the code. It says enter username. I type down admin, for example. Admin is one of the usernames that you see here. And I enter and it says enter password. I type down 1234. So the password of the admin is 1234. When I enter, it says login successful because what we entered was found in this dictionary. So if I run one more time, the username I type down Reza, but the password I type down 1234. So the username is not correct, but my password is correct. It is saying user not found. So this exception is thrown and it is caught here in the except block. So if I run one more time, so I type down, for example, admin, so the username is correct, but the password, for example, instead of 1234, I type down 4321. It says incorrect password. So this is how actually we can simulate a login system in Python, and we can show these messages in the output to the user so they can understand, okay, you had an incorrect password, for example, you cannot log in, try again, for example, something like this. It would be very helpful to have in login systems on different websites to access profiles. Thank you for watching.